This is the waves basics practice, and so this is just learning the different parts of waves and how to interpret waves and describe waves. And so this first wave that we're looking at is a transverse wave, meaning that it goes across this rest position. So if we had a rope and we just laid it flat, it would be on the rest position, it's not moving, but then if we move that up and down, it's going to create these up and down waves. And so there's some different parts of the waves. The first part right here is the wavelength, and so we can write here wavelength, and that goes from the very top of one wave to the very center and top of the next wave. The next part that we need to know, this down here, the bottom part, is called a trough. And that's the lowest point of a transverse wave. The opposite of a trough is number 4, a crest. And by default, the last part, 3, which I like to draw it more like this, it is how far away the medium vibrates away from the rest position. The maximum distance it vibrates away from the rest position. That's called amplitude. And so number 1 and number 3, these are parts of the wave, but they're more like properties of the wave or things that we can describe about the wave, because not every wave has the same wavelength. Some waves are closer together, so they have shorter wavelengths. Some are further apart. Some waves are taller than others. They go up really tall. So down on part B, we have 2 different waves, wave A and wave B, and we have to measure some things. And so in class we actually got rulers out and used our rulers. We used the centimeter side of our rulers, the metric part of our ruler. And so for wave A, it says measure the wavelength, and I'm going to color code these for you guys. So measure the wavelength of A in centimeters. And so remember, we're going to go from the very center of one wave to the very center of the top of the next. It's how long are these waves, the length of the waves. And so if you put your ruler right up there, it's not at 1, it's not at 1.1, 1.2, it's right at 1.2 centimeters. And so we'd write 1.2 cm. Because if you remember, on a metric ruler, each of these littlest lines are 0.1 centimeter. And so from 0 to 1, there are 10 millimeters, or 0.1 centimeters. Next, it says to measure the wavelength. So again, we're going to measure how long the wave is of B. And so from here to the very center of the top, or the crest of wave B, and we are going to set this right up there. And if you notice, this one is right at 3.5. So 3 and 4, so between that would be 3, 3.1, 3.2, 3.3, 3.4, 3.5 centimeters. And that is the wavelengths of these 2 waves. The other property that we can measure is amplitude. And so amplitude is the height of our waves. And so that would be from the top of the crest to the rest position. You could do over here as well, but it's probably easier if you have a crest to just go from the crest to the rest. And so I'm going to put this right up here, and if you measure up, it's not quite at 1.5, which some students wanted to say it's at 1.5, but if you look, 1.5 is right here. So it's one below that, or 1.4 centimeters. Measure the amplitude of wave B in centimeters. So again, we're going to go from here to this rest position. And so if we measure up, it's right under that 1.5, so it's again at 1.4. So what do we know about these waves? They're both transverse waves. So if we were to compare and contrast, what do they have in common? They're transverse waves. Which in class we said that transverse waves need a medium. And if they need a medium, they are mechanical waves. They have the same, what's the same about them? It's not their wavelength, it's the same amplitude. So then what's different about these? One thing is their wavelength, right? This one has a much shorter wavelength, so A has shorter wavelength. B has longer wavelength. Something else that's different, and we don't see this, we can't measure this necessarily. I mean, I guess we could. If we know that each of these are taken in a 1 second time frame, we can find the frequency. And so here we have, we'll say that this is one wave, 1, 2, 3, 4, 5, 6. So this is 6 waves per second, or 6 hertz is the frequency. This one we have 1, 2. So that's 2 waves per second, or 2 hertz is the frequency. Because frequency is the number of waves in 1 second. Okay, so they don't have the same frequency. A has a much higher frequency. All right, then we go on to this back side. What kind of waves are these? And these are longitudinal waves. They're actually sound waves in which something is pushing the air particles forward and backwards, which has a higher frequency. If we go back to what it said before, frequency is the waves in a given amount of time, or waves in a second. And this one has 1, 2, 3, 4, 5, 6 waves. This one has 1, 2, 3, 4, 5. So A has the higher frequency. Label the rarefaction and the compression with an R and a C below. So this cluster right here of air particles, that is called a compression. So you could have just wrote C for that. And this is a rarefaction, where the particles are all spread out. E, a wave transfers. A lot of students want to say particles, because here we see the particles that are moving, right? But the general definition of a wave is the transfer of energy from place to place, because yes, mechanical waves can vibrate mediums, but not all waves need a medium. So what is the definition? It's a transfer of energy from place to place. True or false? All waves need a medium. That is false. Mechanical waves do. But not all waves need a medium. What is the amplitude? And so if we go back to what we talked about before, amplitude is this. And what's the best way to describe that? It is the height of the wave, or maximum distance medium vibrates away from rest position. It's probably good to know what are the rest of these things then. The length of the wave is the wavelength. How many waves pass in a given second is frequency. And how far a wave travels in a given amount of time is speed. And so these things, wavelength, frequency, speed, and amplitude, those are the 4 properties that we learned about waves.